Okay, questions. So one question that I understand came up is how do you know, so go ahead and click and close for a second. Let's get everybody engaged in this. So I'll let you guys answer this question. So how do you know if you're dealing with a kinematic situation when the speed is increasing or decreasing? How are you gonna know? Okay, well, speed, okay, I mean, yeah, speed's the absolute value
I just
of.
remember that's what it said every time I got it wrong. It would say, remember, speed of the opposite value.
Yeah, I don't think that, yeah,
Every time I got it wrong.
I don't think that helps very much.
The invisible hand.
Yeah, the invisible hand helps. Think about the criteria that you're gonna have to have for speed to be increasing, right? Velocity is a vector quantity, it can be positive or negative, right? Acceleration is a vector quantity, it can be positive or negative. Speed is not a vector quantity, it is neither positive nor, it's always positive, it's never negative, right? It doesn't matter which direction you're going in, like if I'm walking along the front of the room, that's the negative direction, but my speed is positive right now, right? It's always positive. Speed is just a magnitude of velocity, right? So you tell me, just yes or no, is my speed increasing right now?
Yeah.
Yes, it is. Pretty good running club, huh? So it's increasing. Is my speed increasing now? No. It was decreasing, right? Okay, agreed? Even though I'm going in a negative direction, if I'm starting to move faster, right? If my speed is increasing, you can see that pretty vividly. So what would the criteria have to be then for speed to be increasing? Does velocity have to be positive or negative necessarily for speed to be increasing? No. My speed could be increasing when my velocity is negative, as I just showed you, or when it's positive, right? If I'm speeding up in a positive direction. But what would cause me to speed up? What would cause me to slow down? And when I say what, I'm going to be more specific. Explain to me how acceleration and velocity would come into play if I were slowing down.
He would get
They're opposite, aren't they? Right? The acceleration is opposite of my velocity, agreed? And that's going to slow me down. So then what's going to speed me up? If they're the same, right? So either they both have to be positive or they both have to be negative for me to be speeding up. And so all you'd have to do then, if you want to answer that question, over what intervals is an object's speed increasing, we would have to find the intervals where both the velocity and the acceleration were simultaneously positive or where they're simultaneously negative. And so I know what question you're talking about. That's on the 2.2 practice, which one was it? 2.4 practice 2, right? And I think it's near the bottom. You've already done all the work. You already did all the work earlier when you did things like, I think you answered a question that said, when is the object moving to the right or to the left? Agreed? Well, what's the criteria for when it's moving to the right? Only one criteria. Positive velocity, right? When's the velocity positive? When's it moving to the left? When it's negative. And I think later down in that question, a subsequent part, you answered when is the acceleration positive versus negative, I think, right? Didn't you? I think you did. Pretty sure, but if you didn't, you could find out. That's a pretty easy one, right? Because the acceleration, I think, was negative. So it's going to be positive when t is greater than some value and negative when it's less than some value, or vice versa. All you got to do is then just line those up. You got to figure out, what are the only intervals where both the acceleration and the velocity are positive, speeding up there, and then, or what are the other intervals where it's negative at the same time. That's it. Does that make sense? Okay. What else? Homework questions.
Number 2 on that one.
Number 2 on that one. Okay, let me just pull that one up. So this one?
Yeah.
Okay, let's look at that. Yeah, this is a really important. Okay, so part A. They give us this population function, population of a certain state in thousands from 1991 to 2001. So 1991, we're going to say t is 0, 2001, t is 10. Is modeled by this polynomial, okay? Determine the average growth rate from 1991 to 2001. So let's make sure that it's really important that we all understand this. If I'm talking about an average growth rate, what is that? Is that a calculus issue? No, that's a pre-calculus issue, right? That's just, all that is the slope of the secant line from this point to this point on the function, right? And more simply, it's just rise over run. It's just change in p over change in t, isn't it? Right? So that's really just delta p over delta t, which is going to be, what's delta p? P of what? Minus p of what? P of 10 minus p of 0 divided by 10 minus 0. That's it. And there's p. Right? So I'll just evaluate, I got to probably put that in calculator or something. Right? Do that in Desmos maybe. Okay? Does that make sense? Okay. What was the growth rate for this state in 1993? Okay, now at once, what's that implying? What's that implying there? Is it an average? No. If they're asking for the growth rate, they're asking for the instantaneous rate of growth, right? Okay. So is that a calculus issue or a pre-calculus issue? That's calculus. That's not a slope of a secant line. That's a slope of a tangent line. Aha. Okay, so for part B, what they're really wanting there is p prime of 2 and p prime of 10, right? That's going to give us back instantaneous growth rate, rate of change, right? Everybody see that? And then part C, well, let's just look at this. We got to look at it to answer that one, though. Okay, so all right, so here's our function. P of t equals negative 0.26 t squared, whoops, plus 107 t plus 6823. Okay, and I'm probably way off. We got to zoom. I'm assuming really zoom out to see this guy. So there it is. And we want to go from 1991 to 2001. So from 0 to 10, right? Well, let's just get an idea how high we have to go with this thing. So it looks like if we go up to like 1800 or something on that axis. So let's set our, part of what we want to do is we want to get this graph where it makes sense. So let's go ahead and set up the domain and the range that we can see in our window. What should I set the domain to be?
0.
Yeah, 0 to 10. I'm going to do negative. I always do 1 extra. So you can see the axes. Okay. And then the y, we said we're going up to about, oh, it looks like, okay, so on that interval, we could just go up to like 900 maybe, by hundreds. That makes sense? So we'll go
Like 9,000.
oops, 9,000. You're right. There. That better? There we go. So it's using a graphing utility to graph, to graph P prime. Okay, so we didn't calculate P prime, but we can do that. Let's do this. Let's say, let's graph y equals, check this out. We can go P prime of t. That's pretty cool, right? So there's P prime. It's, Desmos will actually do the derivative, graph the derivative for you.
That's crazy.
Yeah, pretty good stuff. So then what is that value? That's about 107. So we got to change our scale a bit, don't we? So let's go from negative 10 to 110 by 10s, how about? So what do you notice? It's about the growth rate. It's decreasing. It's decreasing slightly, isn't it? Okay? Make sense?
I remember I did that one, and my graph was like this. Was the slope was negative, and the right answer was that it was increasing.
What?
Yep.
Really?
Yeah. I said like, what is your graph tell you? It was like the population is decreasing, whatever, and it said it was wrong.
The growth rate was decreasing, or the population?
The population.
Huh. Let's see what.
The population's like the data, which is
Yeah.
increasing is deep.
Yeah, I think that's probably what happened. I think you graphed the function. Now, if I graph the function, and that can be misleading, if I graph the function, we can see that the function is still increasing on that interval, right? But the rate at which it's increasing is decreasing. That's kind of a brain twister, isn't it? Right? Get the idea? Come on now. There it is. Okay, make sense?
Yeah.
Okay? All right. What else? Anything else from the homework?
Try have questions later.
Okay. Let me check something here.